You're about to watch an interview with Casey, and I kind of wanted to add a bit of context. We started talking about game development, and he ends up giving what I would consider a masterclass on building your own kind of game engine and how you should approach your first game. It was absolutely eye-opening and very, very good to me. And it even allowed me to be able to set up a game such that I'm going to be able to scrub playbacks and all of that. And it's just going to make a lot of things much simpler. So I'm very happy I had this conversation with him, and I think that you will like this a lot too. You have bad news for me? What is it?
I do. You wanted a boomer take on something, and I am unfortunately Gen X. Does this ruin the entire stream?
No, I knew you were Gen X.
Oh, okay. So you just want me to do the boomer take because I've got that kind of energy.
You got that energy. But, to be fair, I also contain said boomer energy.
I'm okay with the boomer energy because, I don't know what my phone face looks like, but I bet it looks a lot like that because the presbyopia is setting in. The eyesight is like, I gotta hold the phone. You know what I'm talking about? When the dude is holding the phone like about a foot from their face.
Looking down.
2 feet, yeah. And that's me now because I'm just like, I can't read this goddamn thing. My eyes don't focus close no mo. So,
you got one of those bifocal businesses going on, so you got the lower, so you actually the boomer angle is just bad eyesight angle.
Yeah. So I've got that part covered. As for the rest of it, we'll see what I can do.
Welcome to
Nice.
Costco. I love you.
That's actually pretty funny. I do like a good boomerang angle. Thank you, Pack Tester. On, okay. I'm gonna put you. I'm gonna get your name. I'm gonna get your name on here. When was the last time you streamed? Are you ever streaming again, Casey?
Yeah, I probably will someday, but not for a while. Not for a little while. It'll be like
back in the day, you were like the chief of the streamers.
Yeah, I'm with the original hipsters of program streaming.
Yeah.
I listened to all my code on vinyl.
You actually were a part of the original, like the original ones.
Yeah.
Because that was during the days when it was like Lana Lux was typically the tippity top. She was sitting at like 70 viewers. And then every now and then you or Jonathan Blow would come on and you guys would be like 200-300 viewers. And the rest of us plebs were at like 20.
Well, way back in the day, which would be like 2014 when it started, it was like nobody was programming on there. It was just nothing. It was a wasteland. But the streams got a lot of it. Like early on, they got way more attention. Actually, it was like 800 stream people watching the first day, which was kind of nuts back then.
Really?
Yeah.
When was this?
2014. My first stream. Well, I did 5 streams to test the setup, and those were like intro to C programming, just throwaway streams that I did. And then the first stream of Handmade Hero was like seriously over 800 viewers. It was shocking. And Twitch was like, put it on the front page and they were like, what's going on? And it was like, I don't know. I guess people want to watch this. I have no idea why. That's what happened. And after a while, I think people are kind of bored of it. Like they don't really want to watch somebody actually doing programming for a game.
Correct.
But at first it was kind of a novelty. Yeah.
No, it's very, very true. When I was, because I just recently got done doing a project where we built the Doom and taking Doom and making it so like 1,000 people could see it at once, and then they could use Twitch chat to move the Doom guy around and beat level 1, which they did, by the way. So that was pretty awesome. But nonetheless, like building out that, I hand rolled my own compression.
Okay.
And that, I just did XOR, RLE, and Huffman encoding, right? So that got good enough. It got good enough.
Okay,
Doing that, and then I like cheated with the colors. I went from 24-bit true color to 8, just stored it in 8 bits, so 3 bits to red, 2 bits to green, 3 bits to blue.
Right.
And I did, cut some corners, if you will, to make the thing really, really small. So it went from, I think it was 1 gigabyte a second or 2 cents a second to run on Fly.io down to it was 13 megabytes for 5.5 minutes at the end. So I was like, okay, this is good enough. Like, this is good enough. I think we win. And so I was very, very happy about that. But during it, like when it first started, people were like, yeah, Doom. And then like ANSI parsing, people were like, I don't really care about that much. And then it was like encoding, people like, I don't care about Huffman trees. I don't care about this crap.
Well, you actually, in the lead up to this, I was watching the stream just at the beginning there before I came on, and you were talking about like people saying like, oh, he's just an influencer, don't listen to his opinions. It's like, no, I don't think you understand. If you were to do actual programming full time on stream, no one would watch that. Like, it's not
Yeah.
you get that choice. Like, you have to make a balance of fun, light things to do because
Yeah.
are watching it to be partially educational, but partially to be entertained as well, right? They could go read a textbook if they just wanted pure educational content. So I don't know.
Yeah.
There's
And it'd
that
be a lot faster too.
good mix.
Go read a textbook, and it actually is much faster.
Yeah.
Like people do like the building streams, but the reality is that no one. It's very hard to gather context. So if you just pop into a stream
Yep.
and this person's trying to debug a specific part of some binary
Yep.
thing, it's just like all of a sudden they're just like, dude, I have no clue what's happening.
Yeah.
And that's where I
Yeah.
rely on the speed of my vimming to kind of shake people up and be like, oh wow, okay, the vimming's pretty cool, you know, like yeah, look at me, I'm just
Yeah.
look at me, you know, and so like that part's fun, but it's very difficult to keep it up long term.
Yes. Yes, it is.
Just
and,
because,
and
you know,
it's just a smaller audience. There are plenty of people who would watch that, but it's not 2,000-3,000 people or whatever, and the economics of it are just, they're not there. So you have to have more broader content. I think that's just how it is, and it's fine. I mean, I think it's cool, right? Like I think both are good, so it's not a bad thing. It's just people have to appreciate that. It's like people have to do what people watch. You can't just sit alone with 2 viewers on a stream and be like, here, I'm gonna go type in some more assembly language. It's like, no, it's not gonna happen.
Yeah. And even if you're doing coding, in which you make real progress every time, people will tend to watch more.
Mm-hmm.
But the problem with that is that type of coding can only happen for a fraction of the time.
Exactly.
Because at some point you just
yeah.
Yep. At some point it's the 20%, and that 20% is just like 40 hours of grind to get this one small part out. Like I worked on a flight home from Brazil, which was a 12-hour flight, and it was just me fixing ANSI parsing. Like,
Okay.
That's it. That's all I did for just 12 hours on a flight, and it worked. By the end, that's why I was able to do the Doom game, is because it was just like hard, arduous, really specific, boring, me just looking, debugging, printing, debug, print, debug, print, debug, print for 12 hours straight.
Yep.
And I know everyone in this chat says that they absolutely love this. You know, everyone here is just like, no, not true. I loved it.
Right.
It's totally good.
Right.
And then I always do the same thing. I always go to YouTube and I go to the Vimogen and say, if people loved it then here is my multi-hour coding streams uploaded. It has 60,000 subs.
Yep.
Exactly. You know, where's the Sam and the Capistrano? They're not flowing in right now. No one's flocking.
If you think Surfshark VPN is going to sponsor that, you are wrong. You are not going to find out how to get yourself protected from spies and use Netflix from other countries or whatever the hell.
Yeah, whatever the thing is. It's true, though.
Yep.
I know. So anyway, sponsored by Buttsnake. Let's go.
Dude, if you want a Buttsnake sponsorship, I can hook you up with that. So just let me know.
You have the inside deal on Buttsnake?
Yeah, I have the CEO's ear on that one. So what did you want to talk about today, Prime? I actually have no idea. You said something about game stuff, but I don't know. Yeah, I didn't know what you wanted to talk about. So hit me. What's the topic?
Okay, so there are 2 things that we could chat about today.
Okay.
There's one that I actually find to be a very interesting topic that we could talk about, and I already did a video on it that I thought that just I was just very excited about. I think it actually still is the last one. Where's the your account? Your channel. There it is, dude. They changed it up where it's no longer a button; it's a link at the top, and it's this one, Game Devs. And he does this talk on the Game Devs, and it's really good. So this could be one right here, this Game Dev one.
Okay.
I really liked that one specifically, where he talks about 3 different situations in which he goes through them all, and I can kind of summarize them, and then we can watch his closing argument for it, and we can make a discussion about the word of caution to game devs, or B, you can walk me through. What are the steps you should think of when you're building a game/game engine. So I'm going to build a tower defense game. I did have input that's going to come in through the standard in because how I'm going to build it is a little interesting. I'm going to have a Zig program because I wanted to try out Zig. So I'm giving a Zig a real college effort, right? I got to build something. So I'm going to build a little ANSI text base tower defense where ChatGPT is going to control one side and all of Twitch will control the other side. We're going to see who's the smartest. Are 2,000, 3,000, 1,000 people smarter than ChatGPT? We're about to find out.
Well, okay, so the question I have there before we even start, though, ChatGPT is like wicked slow, kind of, to answer things.
I'm going to do turn-based updating. So every creep will move 1 square per turn.
Okay.
And your tower will fire an X amount of times per turn. Like it will have like just a bunch of built-in kind of things that will just happen on a per turn basis. And that will also give Twitch chat time to vote and kind of say, hey, I like this one much better.
Well, I guess what I would say is I am happy to do either of those things. Does chat have an opinion, or do you have which one would you prefer to do, Prime?
I don't know. I kind of like them both. I feel like we could have a great chat about one. Okay, here, we'll do a poll, and then I'll promptly disregard the poll.
Okay, great. Let's
typically how I do it.
Yeah.
I've learned that chat doesn't even know what they want. They don't even know what they want themselves. What should we do? Talk about the caution to game devs. Okay, can't do that one. I ran out of text.
Yeah, great poll question.
Great poll. This one, it's a very compelling poll. Or like a shape of game, of a game engine, right? You kind of giving me some tips and pointers about that, and how you'd go about it. I feel like that's pretty fair.
Sounds
pretty
good.
Fair set of things.
So I'm curious about this Doom game. So did you took input from everybody and like averaged what they wanted to do or something like that?
Yeah, it's actually pretty simple. So by the way, this is where Go was just so ridiculously phenomenal to type. It's like 16 lines of code. It's wild. But effectively, all it was is that for 250 milliseconds or any amount of time, right? I could just set it whatever it was. I would aggregate chat, whatever came in.
Okay.
And then I would do this in 250-second intervals. I'm trying to make sure it fits on your screen. And so whatever was the most popular character of WASD, or fire or use, or a combination. So you could do like WF.
Yep.
Or, WA, right? If you wanted to move forward and turn. So I had like the combinations in there as well. Whatever was the next most popular for the next 250 milliseconds, I played that key through the standard in every 16 milliseconds.
Got it.
And so it would go through and just go da 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 da. So it's always kind of about a half second behind for everything, which is about as good as I could get. But generally with Doom, it's it's not like it's not nearly as like, oh, gotta be precise. You just have to like look at the zombie guy and you shoot him. So it's close enough.
Yes, you don't have to get headshots or whatever, right? You just kind of like, if you're in line with it, it'll work.
Yep. And so that's all I did is we would just play. So I just play out this. And so then the next 250 milliseconds, whatever this one was, I would then play it out for the next 250 milliseconds, 16 milliseconds at a time. So it's just kind of like always doing it. And I tried making this much shorter. The problem is that you make the cycle too short, and Twitch kind of sucks because Twitch chat, once you get enough chatting happening, it just falls apart, and it just will be empty, and then you'll get 400 lines empty, 400 lines. It just completely falls apart. It's
gonna like buffer them up or something, and then it's getting clogged somewhere, and who knows what's going on, right?
Yeah, it was effectively, it became impossible. And so this was the general idea. That's all I did.
Well, that's really cool. I like that.
Yeah, so it's going to be the same thing for the tower defense. The general idea to the tower, let me tell you about the tower defense, and you can tell me what you think. The tower defense is going to be this. I already built this with Doom, so it just will naturally work, is that I have a Doom program that if I handed an ANSI program and arguments, it will spawn the ANSI program, and then it's up to me to do a little bit of programming to like parse out how many columns and rows there should be to the game. And then it will create an ANSI framer, and it'll actually frame everything out, and then it'll just start emitting these frames.
Got it.
So that's kind of like the general idea, which means my Zig program needs to come in here and do some sweet operations, which I've kind of broken it down to read input, effectively update game state, render, and put to output.
Yep.
And that's like kind of like my effective game loop that I'm going to do. And so it's just like, that's all. I'm just going to keep on spamming that over and over again at 33 milliseconds, whatever it is, because I'm printing out the terminal, so I'm not sure how fast I can actually go. And so I'm just assuming it's some speed. But the game is kind of funny. Here's the general idea of the game, which is there's going to be two sides in a dead zone.
Okay.
ChatGPT will say be on the top. Chat will be on the bottom.
Mm-hmm.
You can't build in the dead zone for some amount of time.
Mm-hmm.
Every 10 seconds, if this was like, or every turn, you get to place one tower. Or maybe we'll make it every 3 turns, or there will be some level of something that happens that will make the game fair. Because at first it was every 10 seconds, but now that I'm including ChatGPT, it's going to have to be turn-based. So we'll each get to place a tower. If you place a tower on a tower, it gets stronger. So you're always able to place towers on a cadence.
Can I interject one question quick?
Yeah.
So is this an ASCII text grid basically that we're looking at, or?
Yeah, it'll be an ASCII text grid.
Sorry, keep going. Mm-hmm.
So here's the things. Here's the rules. 1, every tower has limited ammo. Once you run out of ammo, your tower disappears. 2, upgrading a tower will replenish its ammo plus like double it. So it's like it lives longer. It has a farther range. It does maybe a little bit more damage. So there's some bonuses to that. After a certain amount of time, this middle ground disappears, and you're able to place towers anywhere on the map you want to. But you will get shot by the enemy towers. If you get shot by an enemy tower, you lose ammo. If you shoot an enemy tower, you're losing 1 ammo every shot. So there's like there's a certain an economy going on, if you will. It's a min-max game of some sort.
Gotcha.
And then after a certain amount of time, creeps start coming in on the side. These creeps, if they make it to the other side of your side, you lose 1 randomly selected tower.
Okay.
So whoever can have towers the longest wins.
And what is controlling the rate of the tower construction, or can you literally place a tower every turn, or do you have a?
I'll probably make it so it's like every 3 turns you can place a tower, or every 4 turns. We'll have to kind of experiment a little bit with that, because originally it was every 10 seconds, and the game was going to be a real-time game where it's processing. But then I realized if I'm going to use ChatGPT, we have to have allowances. So I'm going to make it into a turn-based game. So it's like, okay, every 4 turns, so then you'll see the guy go tick, tick, tick. He'll move like 3 times, and then he'll be like, okay, it's turn time. Where do you want to place your tower? What's the goal? And then you'll know every tower's health. I'll have to come up with a way to display health and all that kind of stuff.
So I guess you really need a game designer to come on here to give you any good feedback. But I can tell you 2 things to maybe consider if you haven't already. One is that when a player, if the only thing that they're going to be able to do is decide the location of a tower, because basically you're getting to build one thing every 3 turns, and it's just this one type of tower, you may end up, I mean, it might not, but you may end up in a place where the decision making is too constrained because the player doesn't have the ability to do things like, for example, wait a little longer or invest in something a little bit more. They can place a tower on another tower to upgrade it. So you are making a decision about whether to upgrade the tower, but sometimes that might feel a little too constrained. One of the things you notice when you see these tower defense games is there tends to be a fair number of different kind of routes you can go when you're playing them. And part of the reason for that is because you're trying to make sure the strategy doesn't collapse to a very optimal thing right away, where everyone's like, oh, you just build as much tower as you can right at the front of the thing, and then you right next to it, you build as much as you can. So you kind of like, I guess the one thing I'd be worried about is just that thing where it's like, ooh, I wonder if you might need a little bit more there, like a gold supply for towers cost money, and you can decide to buy, again, not because I don't appreciate the elegance of a design where maybe it's like, simpler, but I'm just like, these kind of games kind of want a little complexity there. Maybe could you get more? That was thing 1. And thing 2 was for your end game, I don't know if just not having any towers left is going to be the thing you're going to want, because you're going to end up in this situation where it means you could just find a place to build a tower that's really out of the way of everything and use that as a way of hanging on a little longer, even if a creep's going to get to one side.
Well, at some point, it will be an inundation of a flood of creeps, right? The creeps are just going to keep on generating more and more. So it's going to kind of force you to spread tower. So you can't have one mega tower. because you won't
Okay.
be able to kill all the creeps. You can't do distributive damage. 2 towers should theoretically do more damage than a level 3 tower by itself, right? So there's going to be and then also I can just place a tower next to yours.
Well, I was just gonna say, like, you might want to consider just the standard thing of like, there's 5 health, so if 5 creeps get through, you die, rather than it removes the tower, which is more about what the other player is doing, like they're trying to remove your towers, right? Especially because which tower gets removed, that could add a lot to especially if that's random. You could have someone getting penalized very heavily for no real reason, and it's like, I don't know, right?
Yeah.
And
This
maybe
also
that's
isn't a
fun on stream,
long-term
but
game. It's an
Okay.
experiment more than, this isn't a game
Okay.
I'm releasing and people
Yeah.
are playing. This is kind of a Twitch chat in
Yeah.
aggregate versus ChatGPT. And then I was also going to do ChatGPT versus Gemini.
Oh yeah, yeah. And what do? You describe them. You're like, at the beginning of the game, you're like, imagine that you have a field of 80 by 30 tiles, and imagine that the person placed the thing here. What would you do next? Is that the idea?
Here, hold on 1 second. I think you'd be rather surprised. I just did a quick, just experiment. And all I did was just send it out this thing. I said, here's a board. You are to place a tower that will defend against creeps coming in on the left and leaving on the right. Where would you like to place the tower? Please respond with this. And just gave him a 10 by 10 grid. And it literally just said 4-7. So I put one in there, put in a creep, and then it said 3-5. I think I skipped it once and it said 5-5. I skipped it a couple times. Then I was like, okay, here we go. Do this. And then it just started placing them, and I started placing them, and then it said 2-4, and 2-4 was actually going to hit this creep. And so I kind of gave it more and more information, and it was able to just effectively start playing the game. And it started kind of catching on pretty quick. And so I'm sure there's a lot of like AI strategy that I could apply to this that I have no idea what the AI, because I just don't, I don't use ChatGPT.
Get the prompt engineers in here.
I'm a boomer. I'm sure a prompt engineer is going to help me a whole bunch. It's just I'm too much of a boomer to use it. But I know that it's possible. It will play a tower defense game if I give it enough information. So I just got to kind of like, I just got to figure out how you do like the context setting. So I know there's one way to be able to say like all of this with much more detail up front. And then you send up small updates. Like I will send just a list of towers, creeps, enemy towers, and it will know the next thing to do.
Perfect. Love it.
Yeah. So.
All right. So what's
fun.
our poll?
Our poll was this. They wanted to hear you give me ideas and talk about the game.
Okay. Then I guess that's what we're doing, unless you override them, which you can. It's your stream.
It is my stream. If you have anything else to talk about, we'll chat about this for a little bit, or we can just go into the other one, which I think would be very interesting.
No, like I said, I suck at game design, so I cannot help you. I just am going to take it on faith that this will be a fun tower defense game, because that's about the limit of my expertise. And I'll be watching. I'll watch when it's up. Yeah.
Okay, it makes sense. It's because the hard part is designing something such that can be played by Twitch chat, which adds a level of complexity.
Yes, it does. I mean, like you said, you do have to keep it really simple so that the input is unambiguous and easy to enter and can be averaged properly, right?
Yeah.
Oh, are you gonna average? Are you going to take the average of all of the people's towers? Or are you going to take the median?
We joked about doing that. Take the average input, but it's so cursed that you couldn't do anything.
It's
so
always
we're just
the center. You always build the tower in the center. Yeah.
So instead, we're going to do the most occurring point.
Okay.
Will be it. And so we could add options that you could spawn a creep, and maybe there's like, maybe there's some sort of points you get, so you can actually choose to skip a level. So I mean, theoretically, I could let chat spam skip, and it'll skip one level, allowing it to potentially build, spawn more creeps. You can either spawn one tower or, get creep points, whatever it is. And so you get like more points.
Got it. All right. So what is like, I mean, I guess the question is, do you have specific things you want to know about game engine stuff that was like bothering you? Or do you just want to kind of talk about like in general, do you, what are some things that I should be thinking about kind of stuff? You know what I mean? Like how should we frame this?
I think a good way to frame this is that I have never really built a game engine. I used to do X and A back in the day. So, I've is-rotted with the best of them. My identity scale, rotate, orbit, translate, matrice multiplications. Okay, I've done it. So I've done only that level of game programming, made a game in it, made a couple games in it, and then never really touched game programming again since then. And so now I'm looking at this and I want to build this nice little Zig game. And then ultimately I want to build something inside Go that's going to be nice for people to develop an ASCII game with. And I've never really built a game engine. I don't really know what it takes. What is a game engine? To tell you the truth, I'm not even sure what a game engine actually is. I use the term, but I don't know what it means. Like, what encompasses
neither does
a game
anyone
engine?
else, right?
Okay.
What is included when you say game engine? So yeah, I mean, it sounds like the first thing about game engines you already know very well because you actually already described it and you were like, here's what I'm going to do, and you said the totally correct thing, right? Because one thing that a lot of people don't know about game engines, because especially if they come from kind of an IO centric way of writing things, which is very common in not only beginner programming textbooks, but also in expert programming when you're talking about things like services or servers. They think, I take like an input stream and I produce an output stream. And if there's no input coming in, I'm not doing anything, right? And
Yeah.
I've definitely had like people ask me before because they're confused. They're like, well, how do the games like keep going, when the people don't do anything, right? And so it sounds like you're already at the point where you get like, oh, okay, so the idea is we're sort of running this thing continuously. And sometimes we get input and sometimes we don't, and that's fine. And that's like, honestly, that's one of the biggest things that is like, okay, just that's a thing that game engines have that's sort of different from what a lot of things have. A lot of things are more like on-demand processing. They wake up to handle something and then they go back to sleep when it's done. But
Yeah.
games obviously are constantly trying to serve new ticks. Now, in your case, I guess amusingly, this one game, I don't know if it's turn-based. In a sense, it might even be more like kind of the server model. Are we just kind of sitting around waiting for a packet from somebody, kind of a thing?
I think it's going to partially be that because we're including ChatGPT. An idea of mine is that I'm going to have to drive some of its behavior through its standard in. So I'm going to have to say, all right, hey, oh, by the way, so just to catch up anybody, building an ASCII game, tower defense. We've kind of talked about it earlier, and Casey's given me some basic tips on how to like think about game development in general, right? Which I think is it's just a very confusing thing, especially for someone really on the like outside of it. Game development feels very, overwhelming.
Okay.
So the general idea would be that I just assumed I would just constantly be ticking, producing frames. And if there's no change between the frames, I just don't send anything to be real-time rendered onto everyone's machine. Because again, this will be all real-time gaming. It spawns from my machine, goes up to the cloud, and then gets redistributed to everybody else's machine so they can see it in nearish real time. It's about a couple 100-millisecond lag, so it's good enough, effectively.
Especially for turn-based, right? Because it's like, look, we can delay those turns a little bit if the problem is not everyone has a chance to see and type it in. That's okay, right? So
Yeah, and Twitch itself is 7 to 8 seconds behind what I see. So it's like impossible for someone to use Twitch chat or Twitch to really play the game unless if it's a really slow experience. So like you can't ever really do that. You just constantly get people behind and doing stuff. It's just they're always confused. And so my general idea was that I'm going to have to make it such that I say when to play around. I'm going to have some sort of driver that's based on input, meaning that when the chat GPT input comes in, it's like, okay, Twitch, you now need to make a decision in the next 7 seconds or something. Like you have to make a decision soon now because chat GPT has decided. Now you need to decide, and then we'll go and play the next X rounds until the next kind of decision point. So that was like my generalish idea.
So I would say, for this kind of a game, usually what you do is you are going to probably isolate the sort of game rules part of something like this, like a traditional turn-based, like it's like I'm making chess, right? Which is kind of like what you're talking about. You tend to take a slightly different approach than if you're doing something like Call of Duty or Doom, like you were doing. And I'll just really quickly say what those two things look like and why, because it's probably not obvious. And just, I don't know, maybe it is obvious, but I'm going to say it anyway. So when you're doing something like Doom, The idea is that the user is supposed to be getting near continuous feedback as to whatever the state of the world is, and they're reacting to it. And when we're doing those sorts of games, it's not it's maybe not the proudest thing to say, but when we're doing those kind of games, typically what we say is, well, okay, we don't assume that the player needs to understand the exact precise outcome of what they are about to do with their move, right? So if they push the button to fire this gun, they don't necessarily know literally what the state of the entire world will be before they do that and after in their head, and then they see that it's good, right? So there's more wiggle room there, and there's more fuzziness, and there's more like the player doesn't have an exact discrete representation of the world. It's kind of fuzzy to them. They don't necessarily know what all the values are. They don't necessarily know exactly where everyone is, just kind of see roughly, right?
They can't assess the situation more than what they can assess in real time.
Exactly. And they don't have precise values, right?
Yeah.
When you're talking about something that's on a grid, and you're talking about a game with very fixed moves, right? Like chess, you end up in a situation where it is crucial that the rules execute exactly, and that the player sees that a very precise thing that they do results in a very precise thing that comes out the other end. Now, the reason that I'm laying all of this out is because when we look at these types of games, and I can actually use an example if people ever watch Jonathan Blow's streams on Twitch, they know right now he's working on a very complicated puzzle game that is mostly turn-based. And this was a big thing he had to do inside the engine to make sure that it was all exact and precise and could still animate in real time and all these other sorts of things. The reason that this becomes a different thing is because you tend to therefore want in your code, just for your own mental purposes, to be able to isolate the game rules to as small and understandable a chunk of code as possible, right? And this is just for you. It's not that you couldn't diffuse it out through the world into an entity system and have it all be sort of more like a Doom game running, but you tend to want to have something where you can kind of condense it into something that's very clear, because you're trying to make this strategy game, and you have to have the rules be very concise and know what they do. So for a game like this one, it typically looks a little different than Doom if done optimally for that reason. Does everything I just said kind of make sense? I'm sorry if I'm just saying stupid stuff.
You're not saying stupid stuff. You just might be saying things that are slightly over my head. Like, I understand these I mean, when I say I understand, I mean I understand in an extremely vague set of terms this array of structures versus structure of arrays. Like that type of stuff I don't really understand, other than I can say the words and roughly draw it. I've never really written it or done it myself, so it's like
that's exactly where I was going with this. And so I'm okay, great, because that's where I'm going next.
okay, good.
That's
because
perfect.
In my head, what I hear you saying is that, I could have event-driven systems. Like, there's a lot of different ways in which you can choose how you notify from one part of your code to some other compartment. I mean, generally speaking, we usually use an event bus, usually a global event bus, and everyone has these fancy ways in which we paint this global event bus, and we put lipstick on a pig, and various different ways in which we've done it. But at the end of the day, it just tends to be global event bus, and we just emit out things, and then you have a chance to react, and then the state, I assume, moves forward one tick of something like that, right? And then every tick you have some sort of processing events, post-processing of events, tick moves forward, at least in my head. And so what I hear you saying is that when it comes to these very precise things, the more localized the code can be, potentially the easier it is to manage this outcome, and not to try to make such a generalized system that it works for all things at all times, but more thinking about the system as working for this turn-based item. Even though there is going to be animations, right? As your tower gets weaker, I want it to turn more red, and then maybe it blinks. When your cursor's on the screen, I want that thing to blink, right? So that's like, so as Twitch is voting, they know where they're voting at in real time. They can see everybody's vote, maybe even a count of like, here's the top 5 positions, here's where everyone's saying they want to go. So it's like, it's a little bit more information, but at the same time, I need to be a way to like highlight that and show it.
So yeah, and so let's go down that road, actually, because that's a good place to go.
Okay.
So sort of what I was getting at with that last long wind up there, and here's the pitch, is just that when we are looking at a Doom style game, and the reason I'm saying all these things is because you were sort of saying I want to look towards a more general purpose ASCII engine, the
Yep.
the XNA of ASCII games or something, right?
That's kind of what I'm thinking at
Right.
some point. Provide some basic physics, some basic blocks, some basic
Exactly.
easy ways to render, and then animations, and then provide a web client that like you can send down an animation and then you never have to send that again. It just knows how to play it. Like things that make a little bit more like over the
Yes.
wire sense, or purely render it and then just do real time rendering and compression. What
Yes.
you know.
And so that's where I was going with all of that, because if you came to me and said, I am writing this bespoke tower defense game, and here is how it works, Casey, and how would you recommend I approach that? I would say to do it the way I just said and go into more detail and be like, well, you're going to want to isolate, basically make a little kernel, and this is going to be a thing that's like effectively just a chess by mail engine where moves go in and state comes out, and we can inspect it, and then we have a rendering thing that sits on top of it, and they're separate because you're going to want to do things like fuzz test the internal kernel and pull it out into a separate piece of code where you run all kinds of bulletproofing on it to make sure it doesn't get into bad states, and then you blah 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 blah. That's what I would
really
say,
cool. Let's
right?
double click on that for a second. Can we double click on that?
But there's a big
Actually, no, you said there's a but. I didn't hear the but. Now that I hear there's a but, there's probably a therefore. So let's
Let me just
proceed.
say the but,
Okay.
and then you can double click on everything you want.
Buttsnake, by the way. Buttsnake VPN, Casey.
Buttsnake VPN, the back door of the internet. So the but is that if you are looking at doing more of a general purpose engine, then really you're going to say, well, okay, how much do I care about making the perfect implementation of this tower defense game? Because the way someone would actually write that tower defense game if they bought the Unreal, or they don't buy it, but they use the Unreal Engine or used Unity, is they actually, like, speaking of backdoor of the internet, they backdoor end up making all of the game rules as weird entity script responses in a general purpose system, right?
Okay.
And this is uglier and more error prone, unfortunately, but that's the reality of how someone would do it, because when they approach an engine like that, you're typically assuming that they don't necessarily have the expertise or desire to write this whole separate little chess engine thing that's going to be the thing that drives the game necessarily. They're going to want to do more something like, I just hooked up the are there any creeps near me property to the shoot the tower property, and I don't know, whatever happens when I did that, that's sort of the rules of how towers target creeps.
Okay, I think I've seen these, like, you know, I've watched Lana Lux and Pirate Software every now and then. They have these like big gigantic boards where it looks like there's like a bunch of almost looks like data tables, like what I would consider a database table with a bunch of what looks like foreign keys going all over the place. And I'm like, is this what I'm looking at? Is this like behaviors and actions of how these things happen?
Like visual scripting, basically.
Yeah, these data flows, something. I'm not really sure, these action flows. I think Unity has it. I think Godot has it. I'm pretty sure Unreal has probably the exact same thing.
Yeah, Unreal, it's called Blueprint, and people do a lot of stuff in that, actually. Yeah.
Okay. So I don't want to go that route. My general idea is that I'm building something that I'm going to use to make games, and if anybody else wants to use it, they can. Sorry, no support, no anything else, but this is something that the general idea is that I'm going to build all the infrastructure for you just to say deploy, and it will deploy a relay. Well, it's really what I would like it to do is actually deploy the game, deploy a series of relays. The relays look up in a discovery service where the game is, hook up to the game, and then you also get your DNS, like, you know, somegame.uuid.theprimeengine.com gets created. And then when you go to that and you WebSocket to it from, say, the front end, it then just receives the stream feed of the game. And if, 1,000 people join, then maybe you have 2 nodes or 1 node. And if 10,000 people join, you have like 4 or 5 nodes. And if the game is really heavy transferring, maybe then it keeps on growing the node. You know, like try to create like a generalized real-time game system with some basic ASCII stuff. Why did I choose ASCII? I always thought ASCII games were really fun. Right? I just always liked the notion of ASCII games. They're just fun.
Well, and it adds some kind of interest to it, because otherwise it's just like, I don't know, I'm just another game serving thing. It's like, it's cool, right? Yeah. It's like, it's a reason why people might be interested in it, because, you know, you got to do something to stand out, right? I mean, And
And
so
then
I think
maybe
it's
you can
good.
telnet or SSH into it, and
Yeah.
then you could also see the same thing, so you can actually play just right in your terminal. And then I was
Yeah.
also going to make a Vim plugin, so you can just launch it in Vim or VS Code, and boom, you're just playing. You're just playing games in your editor because that's kind of fun. You know, your editor's already designed to do this. It's like way slower, but you know, we'll make it work out long as your game's not. I tried to make Doom work out. You couldn't do Doom, but I can do
Oh.
about 500 particle or 500 characters on screen, changing colors rapidly, making fire. So I could do a
Oh, okay.
particle
Yeah.
effect
Yeah.
for fire. So that's like about as much as I could do in NeoVim. And so I was like, okay, this is real. I could make some real games long as it's not everything. And the ultimate goal is to make Vim Royale, which would be a real-time rendered battle royale where you use Vim motions to move your character. And if you use like J, 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 you exhaust your energy really quick because you're not being smart with your Vim moves. You're repeating your character. You're holding down. And then you go into insert mode to shoot or maybe delete. I have some ideas. And you pick your direction and all that. And you can get power-ups to shoot more bullets and all that kind of stuff. And the last person in or the last person out wins, right? The circle gets smaller.
I love it. Okay.
So that's like the ultimate far end goal. But like that's like where I've been building everything from is like, can I make a game engine for ASCII? Can I make it real time so everyone can see it? Then can we make it real time with many views? Then there we go. We've just built like a real fun kind of like project. And so I'm kind of struggling on the, you know, some of the design because it is a rather confusing kind of concept, if you will.
So, okay. Getting back to the actual part that you were asking then about
Yeah, I like the
game-
kernel part. I like this thing because it sounds like this is like how I'd ideally look at software, which is you like build all the logic. It has no like there's literally no touching of there's no syscalls, there's nothing. It's just like a giant logic engine in which I can effectively unit test the shit out of and ensure that like when these actions go in, this predictability also comes back out.
Yes. Now, let me say a couple things about the way you can design those systems and some of the things that you will undoubtedly encounter.
Okay.
So, if you are Stephen Wolfram, and
Yep. I hear he's smart.
and you are constantly troubled by your massive intellect and the fact that you must walk among these mere mortals who just don't understand how everything works, then the way that they do their stuff, for example, is you have this Wolfram kernel for Mathematica that does all these computations, kind of akin to what we're talking about, but wicked complicated, right? And it's just expected that the person on the way in and the person on the way out, it's their problem how users are supposed to edit equations and see the results, right? It's just their problem. We don't care because you know what? The Galaxy brain just doesn't care about your stupid text layout, right?
Yeah, getting the values, that's easy work. It's
Like,
the
whatever.
crunching of the values. That's where the magic happens. And
That's where the magic happens, and that's what we're really all about here. Now, the problem with that, if you've ever used anything like this, such as Mathematica, is that it's always a pain in the butt to actually edit, and the stuff looks like crap when it comes out because it's this giant weird escape gobbledygook coming in, and when it comes out, they can't tell where the things were when they went in, and so what ends up happening is if you design a system where you really say like the kernel is pure and it only deals with just the state necessary to know about the game world, then the problem is you end up with something that's very hard to have a good user interface for. The display is bad because it can't figure out what to do with the stuff that's coming out. Is this the same tower as last time? Or is it a new tower that got created on the same cell and all this other crap, right? And so
I see what you're saying is that you have to build by what you're saying. Hold on, sorry for interrupting you. I just think this is really important to kind of like display where my brain's going.
Yeah.
You have to, in some sense, if you make these pure engines, you really do have to like make a nod towards the front end and be like, I'm going to put IDs on every tower so you can identify you like have to start bleeding out some view logic, if you will, into how the data's stored so they know these things haven't changed.
Exactly right, Prime. And what I'm trying to say here is when you are making something like this, it is critical to go, okay, yes, it would be a good idea for me to keep this code understandable and clean because this is how the actual game logic works and it's how the game will be played. And I want to make sure it's correct because this is supposed to be a competitive game and I want it to be accurate and to know what the actual rules are. If the creep stands exactly in between these two towers, which tower shoots it? I don't want that to be the result of a stochastic entity evaluation order process that's random and just happens to be which entity was first in the thing, because this is supposed to be a serious game where people are playing against ChatBT and we care about it. I'm making up these things, but you don't understand what I'm saying.
But you do technically want these things, right? Like, this should be a game that's highly reproducible, that we can all agree, like, on the outcome.
I mean, you want to see people, at least I want to, when you're describing this to me, I want to see you have a post-game wrap-up where the thing recorded the moves and you can scrub back and forth and go, oh, and then chat said to do here, but he was outside the range of the thing, so it couldn't hit the creep, right?
I never even thought about a post-game wrap-up, but I'm going to put a little... Hold on. I've been holding paper with me a lot lately.
Damn.
I walk around with a notebook, and I find that it's really easy to kind of... You can make some really good ideas if you just hold on to a notebook. I don't know why it is.
You're a real designer. You're a real game designer now, Prime.
Well, it's not Moleskin. It's not Moleskin, so that's like an obvious failure on my behalf.
All right, you're not a California game designer.
I am just not. AAA, not in my books right now. Hold on, I like this. Hold on, replay. Because that actually is like a really cool idea, that I could save off a file and then I could just replay the ins and outs and scrub time and just be able to like see that. I don't know how I would do that. That's a lot of work. I mean, obviously, saying it's cool and actually doing it are two very different things. It's a lot of, you would think it'd be easy. You're like, it already played. It's simple. But those things are always so hard, especially undoing stuff like that. That's like,
Well, again, in this particular case, I think we could set you up for being able to do that in an easier way than you would think, because if you imagine that you have this sort of kernel and that's what's driving what's going on, if we just take the state of that and save it at every turn, that state's going to be fairly small. And in fact, it could be highly compressed if you want, because it's going to be mostly the same as the previous state, just with some changes. So you could probably just delta compress it, just here are the slots that changed. And then
whoa. You're telling me a little XOR RLE? You're telling me I'm going to do a little XOR and RLE and just...
I was literally going to say you could use something as simple as the ASCII thing you just described, and probably you would be just fine, because again, this grid is not that big and there's probably not that many turns in it, so I would just do it.
Correct.
Right?
It's going to be like 20 by 20, if that. It's not probably not even 20 by 20. It's probably going to be like 10 by 20, because, you want it long, not wide. Like it's really not that many bytes that are going to be described here.
So I don't think this is going to be a huge deal. But anyway, let me continue with the kernel troubles thing I was talking about to try to steer you away from the things that I think tend to go wrong in those kind of systems.
Okay.
So the thing that people do with these kind of systems that leads them into trouble, because like I said, I do think it's a good idea to say, I'm going to try and keep my game code straightforward and easy to understand and not just let it be an entity festival, which is what we typically do with things like, Horizon Forbidden West or something. It's just like there's 50 million scripts running and a huge entity tree and all this other sort of stuff and whatever. But in something like this where we care about the game rules and want to be precise, what you don't want to do is be be overly precious about that encapsulation, right? You don't want to go the Uncle Bob route and say, look, this thing has to be completely cabined off, and everything that has to do with display and animation and presentation, they can't know anything about each other, or all of our business logic will fail, or whatever it is, the sorts of things that happen there. So you don't want to do that, because your life will become way harder and you will have to write way more code. So what you typically want to do is still let those systems intermix reasonably. You want to, for example, you already said it, have a stable ID. So we just say, look, we're going to have an array of the towers that are active, and those towers are numbered, 1 through 35 or however many there are, and those IDs will be stable. It will be stable inside the kernel and stable outside the kernel, and when we add a new tower, it always gets a new ID, and that ID will be unique for the tower, so everyone can keep track of what the towers are doing, and it's fine, right? As opposed to, who knows? They don't really talk to each other. We got to parse all these weird messages between them, or that sort of stuff, right? Because you just end up writing a ton of code that doesn't do anything. It's just there. When if you just could have said, look, I need both systems. I need my display stuff and my game evaluation logic to both know that there's storage for a tower, one is storing the game information of the tower, and the other needs to do a bunch of rendering stuff, which is augmenting it. I just want both of those things should be able to exist and know and be the data for the tower, and it's fine, right? Does that make sense?
That does make sense. So if I were to re-say this, I'd say the first thing you need to do when you're building this quote unquote isolated game, the game logic block, if you will,
Yes.
that you should always build it with enough data that if you had to make it render, you would have everything you need state by state to be able to render unquestionably given a state blob.
Yes, but I would try to say one thing just a little bit slightly different than that, which is that this game state should be easy to augment with anything we need. And that can be external to the system if you want, meaning if I have data for towers that is used by this evaluation kernel, the game rules. So I have the data for the towers that's used by the game rules. I need to be able to augment that any way that I need to for animation and things like that. And if that is hard to do for some reason, which often
I see what you're saying.
Right? Then that is very bad. So let yourself do whatever you need to do in your system to make sure that you can add as much information that is not used by the game rules, that's just for animation. Let it be able to do that, right?
And then that animation stuff was probably not serialized. You just recompute the animation when replayed, typically. And so how I think about that, when you say it that way, I'm gonna throw up a little bit of Zig on the screen. And I'll just do it at the very tippity top. If you're not familiar with Zig, Zig is just more friendly C. Is probably the best way to put it. I'm only getting started. I'm only just a few hours into using Zig. Like when you build an interface, here's an interface. I have to build a V table with how to do that, and I call it underneath and all that kind of stuff. And I have any opeg is effectively a void star. They're the exact same thing. So, anyways, I wanted to investigate a little Zig while building this.
Hey,
because who doesn't want to build a game you've never built? And then also do it in a language you've never done. Broke one of my cardinal rules, which is never do a new language on a new problem. But here we are. Anyways, so you could imagine that I could have something like this. Let's just call this thing a tower, right? And let's just pretend this was part of the language. So I'm very bad at Zig, so forgive me if I forget these things. But you could imagine that I could have something like render data that is a void star. Yes. It's just like, I don't need to know what that is. You just hand me a pointer, and I know that that pointer exists. So when you look at my object, this thing could really be some sort of like tower view that has, like its current color, right? How long it's been, time since created, right? It could have like all this stuff that's going to help me kind of like animate it and do all that stuff. But to me, it's very opaque. Like, I just know that it exists. I don't have to know its interface. I don't know. I'm just the engine. I don't care what you have. You just do that. That's your piece. Is that what you're saying?
Yes, and I would say it even stronger than that, which is I don't even care if it's some separate pointer, right? You could literally have a struct that's like, comment, this is the render data, and then all the render data is there, and comment, this is the game data, and all the game data is there. The mental discipline of saying I'm going to write the code so that the game data just uses the game data is what I care about. And if you need to use some language feature to help you do that because you know you won't do it, that's fine. Make it an opaque pointer or do whatever you have to do. But all I'm saying is make sure it's easy. Make sure you're not jumping through hoops to add state that's necessary for the animation system, because if you do that, you will end up massively overcomplicating your job, and you will end up typically with worse code because the more code you write, the more bugs there are. I mean, that's just how it is. And if you generate work for yourself, it becomes bad. So you really need to think like, okay, animation and presentation on the screen are crucial things to a game. They're not some weird second-class citizen that only happens sometimes that we, didn't really plan for. So, yes, make sure you know and isolate mentally what is the game state and what will I be saving. But then don't make it hard to attach as much render data as you need to that system however you want. Right.
Okay, that's super good advice, in the sense that I would have probably never been just like render fields, and been and then just put my render fields in there, because that like in my head this feels dirty, like in the sense that I'm just like hack and just making this ever growing structure, and this feels quote unquote simpler. But
Yeah.
you are right that it also is just super one-dimensional just to have all the information you've ever needed on a single struct. And that way it's just like, I can work with that. It's very, very simple. And it's up to my testing and my asserts effectively that I'll sprinkle through my code to kind of validate that I'm not touching these things, that it doesn't matter what that data is. It can't screw up the actual logic part of the engine because that's irrelevant data to me.
And I always try to emphasize this to people. And I don't know if it works, but I try very hard to emphasize the reason that you would do something like separating something out into two separate structures, like I have the data for a tower, that's all the data that might ever be known for a tower. There's only two reasons you need to separate that into separate pieces. One is if you have some algorithmic reason to do so. I was trying to optimize this thing and I needed the prefetching to be better, and these things were like intermixed in a bad way, so I separated them out into two arrays for performance reasons or something. That is a realistic, correct, machine-focused way to have done that, and I would never tell anyone not to do that if they needed to, right? But then the other reason is just mentally I needed to do this because I know I will make this mistake if I don't. And that is also a valid reason to separate something into two structures. But you have to remember that that is the reason you're doing it. It doesn't produce better code for the computer. It just produces a system that may catch some bug that you have. And if you yourself are not actually really worried about, or you don't make that kind of bug very often, then really you're just wasting time by doing that, right? And so I try to emphasize to people, look, you must know by now. I mean, you definitely know because you've been programming a long time, but someone else, I'm like, you must know after a year or two of programming or something, you know what kind of mistakes you make, and you know what kind of mistakes the people on your team make. Think for a second, go, is the thing I'm doing actually going to catch anyone's bugs here? Or am I just creating more work and more confusion by separating these things out? It's the data for a tower. I'd like to see it all in one place. But, well, actually, there's this reason why I think we should separate it because we know some people on the team, they always go grab fields they're not supposed to. We're going to separate it, right? These are reasonable things to think through. And again, I'd never stop anyone from doing that, but know why you're doing it. Does that make sense? And if you have to do it for your own, because you know you will be more productive if you do it, that's okay. But don't just do it because somebody said to in a book. That's not a good reason, right?
Okay, yeah. Because I always tend to separate out these things just like by sheer force of habit, and I'm pretty strong in the camp of don't abstract when you don't need to.
Exactly.
But this might be the furthest don't abstract when you don't need to I've ever seen. Like if you would be like you're like I don't know what I can't think of any good way to describe the two differences. I'm like blue, you're royal blue in this case, right? Like you're very blue, and so it's just like okay, maybe I could do that. It just feels weird to me to do that.
And I
totally see that.
You may not want to, right? Because you may find that this is a mistake you make. This is why I say I always try to emphasize program you make. If you're making a structural decision that's not for a performance reason, then it should be because you know or think you have good reason to believe that it will save you programming effort because you make these kinds of mistakes. And I say this very often. I said it just the other day, in fact, when I was talking about some other things on my Substack and stuff. I make index errors a lot. If I have indexes to multiple things where I'm like, this is an index into this array over here, and this is an index into that array, I will screw up like, oh, wait, those indexes have to be changed in this way to look up into this thing, and I forgot to do it, right? So you will see in my code, I create little structs for my different types of indexes, and I force myself to use those instead of like ints, right? Now, why do I do that? Computer does not need that. That is not helping the CPU. At all, right? The CPU does not care. It's an integer at the end of the day to the CPU no matter what. Why do I do that? Because I know I make these mistakes. And so I take the extra time to put that in because I know it will save me time later. And so, again, you will know And you need to trust your own gut because you will know. I can't know what mistakes you'll make, but you will know what kind of mistakes you're going to make. And like I said, you'll often know what kind of mistakes your team makes after a while too. And so you'll know these things, and you should know. So I would never tell you one way or the other whether you should split the tower structure or not. I would say, Prime, you should know. By now, you'll know what you're going to do, and you should make that decision, and I trust you. I trust you to make that decision correctly, right? So yeah.
I like that. I like that a lot. I got a lot to think about with that one. Hey, by the way, sorry for interrupting. Hey, we just got rated by EJSA. This is the second time you've rated me before with 691 viewers. Hey, I appreciate that. Let's go, EJ. What were you doing today, EJ? This is the second time he's rated me, but I cannot seem to remember what the first time was about.
You know who else we just got rated by?
Whom?
The Puss.
Damn. Look at that cat. EJ does space stuff. Ooh, what kind of space stuff? Yeah, we got Molly Rocket on here. Okay, for the Starliner launch. All right, we're watching the Starliner launch. I do rockets. What you do with software. Okay, you do with rockets what you do with software. That's cool. All right, well, hey, that's a shout out right there for sure. For sure. There we go. Hey, appreciate that raid. We saw them fling 2 humans into space. Yeah, that's brave people out there. You just reminded me of something with how you had the cat tail near your face. I had during my wedding, the person, the wedding officiator. What's the name of the person that does what's the name?
I don't know.
He's not a priest because he wasn't a part of the Catholic Church.
Right? Yeah.
He was a pastor of a Christian church, but
okay.
I don't know what the proper term is for that. There's a wedding officiator. We'll call it that. Whatever that is, an officiator. Yeah, we'll call it that. A celebrant. I'm not sure what that means. The linker.
The linker.
There we go. He's the linker. Hopefully, this wasn't a mold one either. This wasn't fast. Okay, so he had this feather. He had what do you call this thing? The thing that's also on your chest. It's not a cummerbund.
Corsage?
A corsage. Yeah, corsage. Yeah, and the corsage had a feather, and the feather was perfectly going right into the corner of his mouth.
Oh no!
And the whole time he was talking, it was just like wiggling in there, and I couldn't stop looking at it. And at the end of my wedding, I went to my wife and I was like, "Dude, did you see that feather in his mouth?" She's like, "That's all I stared at. I don't know anything he said. All I saw was the feather just going in and out of the man's mouth. That's it." So when you put that little cat there and the tail was right next to your mouth, I immediately was just like, "BJ, feather." His name was BJ.
Oh, and there was a feather going into his mouth. Okay.
Yeah, the whole time. Yeah, I know.
What an interesting name for someone who has something going into their mouth in the middle of a proceeding.
Life is art, but unknown to thee.
Yes.
It's just a classic.
Very well said, Brian. Very well said. Okay.
Anyways, I got feather-mouthed. Yeah, it's the old feather-mouthed linker. Anyways, I don't know where I was going with that story. Just something that you remind me of. All right, so for those that don't know, Casey, why don't you give a quick description of yourself?
Oh, there's nothing to describe. I'm an old programmer, worked in the game industry a lot, and I am just on Prime Stream right now. We're talking about how he might implement a tower defense game in ASCII art for a project he's doing. And it's going to be like a Twitch chat project where you can sort of play this tower defense game. And here's the thing. It will potentially be against some of these newfangled AIs like ChatGPT and Gemini. So you can see if the humans really will win the war against Skynet. Like, will there be a John Connor on the chat or not, is basically what Prime, I think, is going to figure out with this experiment.
Yes. Does John Connor exist in aggregate?
Yes.
Or are we just all screwed? Because I don't think the one John Connor can exist. You really need the fleet of them to really be able to, charge humanity into the future.
We are all John Connor.
We are all John Connor. Or we're dead. One of the two.
Yeah. Hey, there you go. It'll be brief. So back to where we were here. So, yeah, I think we pretty much covered that stuff. There, again, it's not really, it was really just a word of vague caution to say, don't try to over-engineer this kind of system, because especially when it's your first time making a particular type of game. So I haven't made 50 tower defense games before or whatever. You're going to be in a mode where you're figuring out where things should naturally go and what they should naturally look like in this kind of code. And the last thing you want to do is add a cost to you going, oh, you know what, that really should have been game state, or you know what, that really should be render state. You don't want that to cost. If it does,
Yeah.
it's going to take you longer to iterate and find the correct way in which things work, right? And so when you're initially doing this kind of design, and especially when you're designing the game as you do it, because you will be like, as you get in there, you're going to go, oh, you know what, this design idea I had didn't really work, but I got an idea for a better one, and I want to put that in. It needs to be fluid. And so you really don't want to put extra weight on these systems. You can always extract that stuff later if you feel like you need to, but when you're in there, it has to be kind of fluid, and you need to be able to rapidly do whatever your idea is and see it come to fruition, or the game will suck because you won't be able to do that kind of experimentation and get it going, if that makes sense.
Okay. No, that makes a lot of sense. That makes perfect sense. I definitely, it's going to break some of the normalities that I'm used to.
Yes.
Especially if I like pile all the data in. I still might not do it just because I'm just so used to having a
you
different way of doing things, just to like do it the way I would expect myself to do it. But I think the big takeaway here is never feel bad cutting a corner if you're cutting the corner for ease of centrality of information. Is that a good way to put it?
And just flexibility, not having to think about it, right? Because the more you have to think about the structure of your code when you're trying to implement something in a game design, the less you'll be able to experiment, because you're spending mental energy worrying about structure. But structure doesn't really help you that much in game design, especially because you can always do a pass afterwards if you really need to like separate things out, right? If you're concerned about it. So it's important to recognize that there will be that conceptualization phase as well, and experimentation, and you really just don't make extra work for yourself. Like, no, feel it. You know how to you know this, right? You've been in code bases where you're like, God, I can't change anything. It takes me 3 days to write. Just don't let that happen. Whatever you have to do, don't let that happen, right?
I do think that there is something interesting to this, which is I think the proportion in which you can apply the rules you are speaking is the duration of the game you are creating. And so I have a definite start, I have a definite end, and like at some point there's just like no more, right? I've decided the input, I've decided the play. I'm not going to extend this. If I do it, I'll make tower defense, electric boogaloo, right? Like we'll do the next version. And so it's like, okay, make it what it's supposed to be, and then just like make my worldview, and then from there I've learned and I can apply it to the next round, as opposed to, if I was trying to build something that has to be around for 10 years and gets regular updates, I may want to make a slightly different effort. Maybe I use a couple extra interfaces that I normally wouldn't be using.
But not up front, and this is the key part. If you actually want it to be good, you make the tower defense game first, and you learn what the structure actually looks like, and then you work backwards from there and go, what interfaces make this kind of thing easy to express? And that's the money right there. Going the other way and going, what interfaces will I need up front? That just locks you into a structure ahead of time that might be wrong.
Yeah, that's a very Go way of thinking about it. I think the Go 100 mistakes, I think number 5 or number 6 is let interfaces effectively naturally percolate. Don't opt into an interface.
Exactly.
Refactor to an interface when needed.
That is perfect. Perfect. So let me give you a quick example here just to solidify what we've been talking about too, because I assume this one will be probably the one that you would hit roughly first. So let's suppose that we make something like this and we say, okay, so we got to get started somewhere here. So we're going to have a game board, and then we're going to have to decide how we're going to store our entities, because, these towers, and when we say entity in the game industry, it just means, there's things in the world that have to be simulated. So we've got some creeps and we got some towers, and you can make different decisions about how you want to structure those. People do it multiple ways. One way is that everything in the system that has some kind of a gameplay effect is an entity. That would mean that towers are entities, and creeps are entities, and fireballs that take some time to go across the screen are entities, who knows, right? And then entities themselves have distinguishing characteristics in them, such as a type field that says which one it was, or it has something like a flags that say what sorts of behaviors it has, or things like this. And then the entire thing is just, they're all entities, and we process entities. That's what we do. Another way to do it is we have specific types of things. So we have a set of towers, a set of creeps, and a set of fireballs, or whatever it is, right? And you're going to do something like one of those. We can talk about the ways those work as sort of a separate discussion. I don't know if we want to do that today, later, or if it's just the stream gets too long and we do it a different day or something, we could do that too. But at some point, you're going to decide those things. So you're going to end up with a thing that looks like, all right, I've got some data for these things on the screen. Let's take towers to start with. And a tower has something, let's say it's got health, or you said ammo was a thing it has.
Yeah.
So a tower's got to have something on it like properties. How much damage has this tower taken? Now, in the kernel, right, if we just want to talk about the game rules, and the whole point of this system is just to output a who won at the end of it, right? That's what a game kernel does. It's just like you feed in all the moves and I tell you who won. That's all it actually needs to do correctly, right?
Yeah.
Everything else is display, right? Well, at some point, a tower is going to get to 0 health, or whatever it is that the thing that removes it. 0 ammo. I didn't quite catch from your description what causes the tower to die. I think you said
0 ammo. When you get shot,
ammo.
you lose ammo, and when you shoot, you lose ammo. So it's
Okay.
like you have one axis of health, which is
One
just how
axis.
much ammo you have.
So when the ammo gets down to 0, the tower gets removed. Well, if you get down to 0, then in the kernel, it can just remove that tower, right? So if you
Yeah.
imagine just a pure implementation that didn't care about anything else, and I'm inside the kernel, we go there, I remove this tower, it's gone. I collapse the array even if it's in there, or if I have an object pointer, I deleted it, it's gone. That would work, right? However, on the outside, now think about what happens to the animation system. Well, when a tower goes away, right, not only do I need to know that that tower went away, so we still have to have an understanding that there was a tower, where it was, and that it went away, but I also probably need to do some fancy schmutz. The tower has to crumble over a series of frames. It has to explode in a giant diehard gasoline fireball or whatever, right? And so the reason that I was pointing out this idea that, like, you can't be precious about the kernel is because now if you literally made a kernel that just deletes the tower as soon as it dies, you've created so much more work for yourself, because now it's like, oh, wait, but how do I discover that? Does the animation system just look and scan the list of towers and find out that there isn't a tower anymore? And so it knows that it had a copy of a tower and it doesn't see that tower, so that tower should get destroyed? Or do I have an event list that says tower destroyed and here's where it was, and the animation just releases the event list? Don't think about those things. Those are wasting your time. Instead, just keep a stable array of towers. When one dies, mark it dead and let that just work. Save yourself the trouble. Computers have 64 gigabytes of memory or more. You will not run out of space to store dead towers. It's fine. So when I say try to simplify things and don't go crazy with the separation, that's the kind of thing I'm talking about. Does that make sense?
Okay, that was really brilliant. That was really, really brilliant. So how I kind of put it, I wrote down a note right here and said put two-sided death, effectively. There is the literal death of the tower. It ran out of ammo. But then there could be, like you said, the animation. Maybe I want to make it actually like fall apart. Like it actually has flames. It has something. So you know that it died. And that, on the other hand, is an animation side. It has no influence on game state. Game state,
none.
It does not exist. It can't hurt anybody. It doesn't block creeps anymore. It is just what it is. And so, therefore, the animation's purely a pretty side of things. You could just make it disappear in the UI and bada bing, bada boom. You're now just adhering to a one-sided death, if you will. But it sounds like having the idea of a two-sided death is really important. And then on top of it, these towers are taking up, 400 bytes at most if I'm like going crazy out there? Yeah, and so it's just like maybe that doesn't matter if I have allocated a 10 megabyte array, right? Like that's I have a lot of towers to make, and these games are probably going to be 5 minutes long. Probably not going to run out of space anytime soon.
And so take that example and just imagine, because this is the truth, when you actually make a polished game that you have to actually ship, every last thing is that same thing. Health. You don't want it to immediately just tick down to a lower level. Ammo, you don't want just immediately tick down. You want to show the bullet in the little ammo display flipping out and doing some kind of cool animation. You want to have the health meter slowly interpolate down to another value. So there's always this state that gets stored around. And one of the biggest mistakes people make when they're programming these kinds of things is they massively they do the kinds of stuff I just said. They duplicate their efforts all over the place and make event systems and multiple storage for all these different things. And the animation system, there's a separate thing for every health meter, and it has to get updated with the state. All of a sudden, you're spending all your time maintaining this code. There's bugs everywhere where the health meter isn't correctly tracking whereas if it was just one freaking value called current health, and then another floating point value that's like animation health, we're done. Yeah. And it just works. And they chase each other over frames, we're done. So
something like this, where you have like display ammo, which is like, or this is your ammo. This is literally what you have left. And then this is like, how much am I currently showing I have?
Yes.
Oh, man. Yeah. No, dude, I would have totally ran into every one of these problems. So far, this is just like genius level stuff that's so obvious. The worst part about this is that all of this is so obvious. This is how I would have done this 15 years ago. Well, like, that's the worst part, is that I've learned not to do this just through, other types of development, if you will, and other influences. It's like, it's blindingly obvious, as someone just said in chat.
It's blindingly obvious only once you have been bitten by it, right? That's the thing, because everyone, it's not genius, it's experience of getting screwed and looking at what happened and going, why was this so hard? Right. And so like, it really is just a case of like, the things I'm saying are just like, this is what actually happens in game engines. And people struggle with it every day. It keeps happening. And as new people come in and they keep having to learn this lesson. And then when they're 40, they're like, oh crap, like this really sucked and we got to do it better. Right. But so anyway, that's the main thing I would sort of try to get you on the right track, right? For that, because again, you would have learned all this stuff yourself. I guarantee you would have. I'm just trying to save you that year of pain.
It might have taken like 5 failures for me, honestly, for me to learn, or for me to go through this. This is a lot. This is like a decade of game programming experience all coming to head. And it's because I think the only reason why I would really ever know this is because I'm building it myself, as opposed to, like you said, using the Unity thing, just doing the drag and drop arrows and all this. And, the system, even though it's very, very complex, it's already been created and it works pretty well. So it just works over there. But since I'm building this, I'm not going to build that system. There's no reason for me to try to build that system. I should just build the simplest system to make the game a success.
Exactly. And it's the advantage, the massive advantage you have over not using something, like if you were to use Unity or something like that. And so you want to take advantage of it, because if you're not using a pre-made game engine, you're obviously taking on a lot more work. You have to write all of the things that the game engine was providing. So you're at a disadvantage there, right? Because you don't have all that stuff that Unity provides. Don't then also cripple yourself by having to implement all the bad ideas from Unity in your thing. Take advantage of the fact that you can do things really simply like this and get a lot more bang for the buck without having to have a giant rat's nest weird diagram with lines flowing all over the place just to display your health bar, which is what they have to do in Blueprint, right? So take advantage of the fact that you are programming directly and you know what you're doing. Use that, and don't be afraid of it. Yeah.
Okay. Yeah. This is, someone just said in chat earlier, which is actually in some sense kind of ironically funny, though it's like tongue-in-cheek true, which is that mid-level engineers are more dangerous than new engineers, which is kind of a fun idea, because there's a lot of built-in conceived ways you should do things. And so this is a leap in my thinking when I'm building these shorter-lived things, is take advantage of locality. It's funny because this is like a completely orthogonal viewpoint from a person named Carson Gross. And I don't know if you know who Carson Gross is. He created HTMX. And if you don't know what, by the way, HTMX mentioned, but if you know HTMX, effectively what HTMX is really, really known for is that it's a simple set of utilities to add to DOM elements to make the hypermedia what he would consider complete. So you can imagine you have a div, and you could add hx-get, and you could put in a URL, and whatever comes back, the HTML that comes back from that URL gets swapped out inside this div when you click it.
So it's basically like an iframe that actually integrates into the DOM properly instead of its own garbage
One
rectangle.
way to look at it. And there's obviously there's a whole bunch of things you can add to it, like what type of events should it do this on. You could do a post, a delete, a update, or a patch / put. There's like all these other things you can do. But the big thing that he stresses is locality of behavior.
Okay.
Right?
Yep.
Which is that you should be able to look at one spot in your code and you should understand how it's rendered, where it got its logic from, how it did all these things in a very tight spot. Because in our modern world, we have things extremely decoupled. You have an API somewhere that gets data from somewhere else, that morphs it into JSON, that takes your view, crawls all of your business rules, produces a JSON view. That JSON view gets serialized, deserialized on your client side. You rewalk that structure and effectively do the bizarro Batman rules of undoing that and turning it into a new structure that is now then going to be put in or integrated into React or behaved through something like Redux, and which is going to send out a bunch of global event buses. It's like, no. Instead of creating 18 points of change, let's create 1 point of change. You call here, it goes there, it goes back in here. Like, let's make this much, much simpler kind of form of web dev that's going to solve 90% of the problems. You know, there's always going to be Google Maps or an Excel spreadsheet, which this is just like this is just not the right paradigm to think about. But you would also not use React either. You'd probably have to hand roll your own stuff because it just would be impossibly slow. So it's like, that just makes sense. And so I'm like, okay, this is effectively the HTMX of programming. It's just like, all right, you know what really needs to be put here? You want your state, but you want your view state. And you want them just like right there so you can just see what's happening. Yes. And when the view uses it, it just knows exactly what's happening. And when the game state uses it, it knows exactly what's happening. And so the missile knows where it is because it knows where it isn't. It's like that. It's like literally
that easy. Yes, exactly.
Good ending, right?
Oh, yeah. That's the perfect thing. Yes. I love that missile thing.
It's the perfect ending to it. But it's true. Like in this case, the missile knows where it is because it knows where it isn't. Like it's actually like... It's perfect. Okay. I like this. Okay, this was like fantastic stuff. And I feel like after I create it, I almost need you on again at some point, and we should talk about like another thing that's like good, because this is already enough for me to go and try to create a game now. I have an idea. I'm going to switch out a lot of stuff because I did a lot of, like earlier, because I'm just trying to get it. In my head, I'm thinking about testing really heavily. And so I want an interface because I need to be able to pass in a non-like part of the game structure, right? I want to be able to have a testing inputter that kind of simulates standard in stuff that I don't have to do the same level of stuff with. And so I'm sitting there thinking, well, wait a second. I really could just make this an enum and just have the test one already inside the code. And like, why am I, maybe I could just be okay just not trying to make this the most glorious abstract piece of code, but instead just be like, here's this, and that's all that there is, and you're just either this one or you're this one, and we'll just do some switches and pop you right out. Grab your type and toss you out.
Yep.
All right, this is good.
So I could keep going, but it sounds like you're done, right? Is that like we're good?
I think this is a good place, unless if we have more along. Do you have more code nuggets along this line, or is it more of like a gear switching type of change?
I guess maybe we could end with just one quick discussion about how these things are going to get evaluated, because that's sort of another thing that you're probably going to have to think about a little bit, right?
Okay.
So the other thing that I would point out here is to apply the same. So you might not fall into this trap because you have not traditionally done much game programming. So what I'm about to say, you might be like, well, of course I wouldn't do that.
Yeah.
But I'm just going to say
I have no I have no experience to teach me the proper way to do it improperly. Like, I have none of that.
Exactly. So you're not maybe going to fall into, and so what I would say is also for a game like this, especially because you're talking about 20 by 20 or 20 by 10 or something, and so the total number of towers and projectiles and creeps and all that stuff is going to be pretty low. Also, just start out doing the dumbest possible thing for how you evaluate the for lack of a better term, collision or physics. And let me just quickly say what I mean by that and what that system is going to be. So, inherent in a tower defense game, you're going to need to resolve spatial queries for a lot of things. Towers need to know what creeps are within their shot radius, because that's sort of a fundamental aspect of tower defense.
Yeah.
They need to pick one of those creeps and they need to shoot at it. If multiple towers are overlapping the same entity, you need to decide, are there fairness rules where towers will do what the game player probably wants them to do and not both target the same entity or target the same entity if it's low? Or do you want there to be things like this or don't you? You're going to need creeps to potentially avoid each other if you want them to walk and like bump into each other or go around each other or attack each other when they hit. So there's a ton of spatial queries, even in a simple tower defense game of the kind you're contemplating where, you know, it's not Dota, but there's still a ton of spatial queries going on. And what's more so, if you have any plans in this game to do things which we would traditionally call line of sight, which means, are there walls in this game? Can I put a wall that a creep cannot go around? Can I put a wall that a tower cannot see past or shoot past, right? If you do things like that, you have an additional type of spatial query, which we traditionally call a raycast, although it's not a very good term for it. And that is when you look to see whether a line will intersect anything on its way between, say, the tower and the creep, right? So when you are working on your game design, you are going to have a ton of those things that you're going to want to do. All of the things I just mentioned, for example, are presumably on the table, and possibly even some more that I'm not thinking of, depending on where you go with the game design or how you are conceptualizing the game design currently. What you want to do here is build something as simple as possible first that just loops over like all the towers or all the creeps, right? Every time n squared, and make it work that way while you are designing the game. Because with a low entity count, even 1,000, n squared for a turn-based game is 1 million, which is no problem for a modern CPU. So what you want to do is do that first, which is something you probably shouldn't ship to customers because of it, right? If this was an actual game thing and we were talking about scaling that, so you wouldn't necessarily. But do that first, and ride that as long as you can until you've got the game design roughly solidified. Before making a collision grid, before making some kind of a spatial tree or queries or some kind of accelerated raycaster or any of those things. And the reason for that is because as you are developing the game rules, you will find that the kinds of questions you're asking change frequently, and you won't know exactly what the kinds of queries you want to accelerate will be until the end. Does this make sense?
Yes. So don't build a quad tree.
Don't build a quad tree. Don't build a KD tree. Don't build a collision grid. Don't do any of those things. Just have the entities have a position, which is their cell location, and do a loop over everything you need to many times in the evaluation of the game state, each time if you have to, and let it be dog slow. But that will allow you to go into those loops anytime you need to and add all sorts of weird checks like, oh, well, okay, but only if the guy is on this side of thing, or otherwise pick someone who's slightly closer. Oh, well, and keep a running tally of which one of these creeps was the highest health and keep that guy because that's what I want. All that crap, just let yourself pile that crap into a dog slow query, because that will allow you to experiment as fast as possible, and that is what matters. And then later, if it becomes a performance issue when we actually need to ship this thing, we can talk about all the baller ways you can make it run instantly, but that's the time to do it, not beforehand. Does that make sense?
Yeah, and you got to remember when I say ship, by the way, this is really good advice, just like don't worry about that. We can make it faster. I'm sure there's already a bunch of pre-written algorithms and pre-written papers on I was doing this, now I'm doing this, it's this much faster. I'm sure there's people that have done the exact same thing, and I can be like, oh, okay, we just need to do this. But one key thing to remember is that I'm just playing it on my machine, and people only have a real-time view into the game.
Exactly.
So there's not even like processing doesn't even exist anywhere. I can guarantee that the computer will be at least this fast.
Yeah, beefy, very beefy.
Because it is the one right in front of me. Like that's the only computer I'll probably ever run on. And so it's like, okay, I can definitely do something here.
Yeah, and
all right, I like this.
And the just to be clear, like, and so I mean, I run a I run a course where we teach performance programming, right? So it's a weird thing for that guy to be saying, right?
Yeah.
And I think the critical part here is just that, like, no, when you don't know what a system does, you can't even do the basic design necessary to make it fast. So you have to recognize which stage you're in. And I would never tell anyone to optimize their code when they're trying to figure out what the game design is, right? That's a bad time to do it. What you want to do is, once you know what the game design is, then we go, okay, what's the system design look like now that we can roll out that makes it fast, right? And so there are two ways you can look at this. In a project like this one, I would follow the advice I said to the letter, meaning don't do anything, do the stupidest possible thing, and then just wait until the end. And if we need to optimize it, we can. That is actually bad advice. So I want to caveat here on a very large project, because what will happen in a large project is that we'll fix it later will never happen, right?
Yeah.
So what you
There's not like a deadline. I don't have a PM. I don't have a,
exactly.
I'm not playing the same set of rules here, so I don't need to find the best solution as quick.
Yes, and so I want to put a little caveat on that, which is like, if we're talking about a serious game project, where we're on Call of Duty or something like this, right? Then you have to take a slightly different approach, which is you have to specifically cabin the prototype stage. You have to go, okay, we have to do a speed run to get our game rules roughly right and know some basic things about the game. But then before we start throwing in 1 million scripts and 50 billion placed entities and all of this game code logic that might all have to be rewritten to make it fast because we didn't choose the right primitives for constructing it, do not let your project get to that point before you've made some performance decisions, right? Because that is the thing that will then absolutely cripple your performance. And you've seen me say it and multiple people say it, hotspot engineering doesn't work. There will be no thing you can optimize at the end of that because the thing has been structured incorrectly, typically because it doesn't have the proper batching. So lots of these, the stupidest possible thing is each entity is going through and we do each entity in order, and then each entity does its own raycasts in order that it needs, and that, right? And there's no batching, and there's no way we can speed it up, right? And so you can't let the project get to that stage where people are implementing the shipping game code, right, without having thought about how the performance is going to work. So don't do that. But in this case, with this game this straightforward and small, I think you probably never will get to that stage. So we may never have that happen. I just want the audience to appreciate that, because the advice changes at a certain point in the project, and you have to be aware of that.
Yeah, I mean, that makes sense. Typically, I try to write code that I call fast enough code to begin with. Like, I knew that when I was doing this stuff with, just taking all the data, and I'm going to have to be XORing these frames and doing all the network encoding and doing all that. I just constantly made the decision, hey, I know it's like a grid, a rows by column, but I'm just going to make it a 1D array. I'm not going to make it an array of arrays, right? I have the pointers all over the place, allocated everywhere. And just like, here's a simple win that's not hard to do. I'll just do the right thing to begin with, and there we go. It'll be fast enough. I'll have nice locality of access going on all the time. This will be fantastic. And so I try to generally make okay decisions. Maybe not the best decisions, but this n squared thing, like, just do dumb collision detection, because you probably will have 75 elements on the screen at max.
Yeah.
And then by the time, when I'm going through it, I'll be going like, are you a creep? You're not. Next. Are you a creep? No, you're not. Like that's a pretty fast loop. That's not something I have to worry about too much.
Yeah, and then so yeah, I don't know how to say it in any other way than I said it before, but I hope people appreciate that difference, because you can't. It is both true that at the start of the project, if you really don't know exactly what the game is going to be doing, it's very hard to structure the code such that you will be able to make it fast at the end. And if you try to do that, you may hurt the prototyping process. But it's also equally true that if you let that kind of stuff go on past the prototyping process, you will completely kill the performance of the project in an unrecoverable way. And both things need to be appreciated. And I wish there was an easy way to give people the rule of thumb of just always do this and never do that. But it just doesn't work that way. You have to have both. You have to have the understanding in your head that at some point you transition into a thing where if you keep making those kind of decisions, the code becomes irreparably slow. And so if that's going to be a problem for this project, you can't undo it later. And I don't know. Hopefully people can sort of understand that those two things are not in tension with each other. They're actually they're actually unified very cleanly. And they unify especially if you think about one other thing, which is that in that prototyping process, think of that also as your optimization prototyping phase. What you're doing there is figuring out what sorts of operations are common in this system and have to be done many times. And
Yeah.
when we figure that out, that gives us now the insight we need into how we should structure the engine to run that quickly. And so the key thing to not forget is you're not just doing stupid stuff to prototype gameplay. Optimization is the root of pre-optimization optimization, the root of all evil nonsense, right? No, you're also prototyping the optimization. You're figuring out what do we need to run quickly. And so consider that part of the goal. Don't lose sight of that, right? And like I said, in this project, because we're constraining ourselves to such an old style of game, right, that could have been run on a very old computer, right? Yeah. We may not have to ever enter that phase, but I just don't want people to get the wrong idea, right?
Yeah,
and there you go.
I see exactly what you're saying.
Okay.
This makes perfect sense. It's just that I have to make sure that when I'm doing what I'm doing, I know I need to gauge the value of the performance much more critically, because it sounds like it's very easy to have this go out of control quick when it comes to game programming. And me, very new in this realm, like, okay, I can take a step back and just do it simple, observe, make changes when I think it's needed. But at the end of the day, this is a 20 by 20 grid, 400 possible elements, which means there's only going to be like 400 possible things anyways. N squared may not be all that bad while I'm learning.
Yes, and then if you actually were to do it in a production environment, like I said, performance decisions like how to structure who queries what and when have to actually be made very early in the project. And that's why I kind of wanted to put that caveat on it, because when you say stuff, like people are in the chat, they say, make it work, make it right, make it fast, right?
Yeah, I don't like that phrase generally, but
it's incorrect, right?
Yeah.
Because if you weren't thinking about how to make it fast at the make it work stage, you will never make it fast. So it's a bad phrase, right? Make it work and figure out what it needs to be fast. That's the first step. Then you make it right. Then you make it fast. That's actually fairly accurate, right? But if you didn't do the structural work to make sure that it could be accelerated later during the first phase, you will be royally screwed.
Yeah. Yeah, no, I've seen this. You see this in most web apps. Like if you
in everything.
You see it, because especially like we talked about this hotspot thing. Hotspot does work now and then, because like you and Uncle Bob were having that discussion where when you typed too long, it would get really bad with these emojis and all that.
Yes.
Right? Like that was a very obvious thing that was a hotspot optimization. You could see what you goofed up, remove that. But those usually are more of a rarity. They're not. Usually it's just not a royal fuck up. It's like this has been a distributed kingdom of just minor screw ups, and now everything looks fast based on a flame chart, because like nothing's using any of the top of chart. It's just the distributed oopsie daisy that's just consistently bad throughout it. And so then it requires effectively a rewrite. You have to like rewrite the thing to make it better, which is not fun.
Exactly. And that's just the part that, that I wanted to caveat there. And if you look at that kind of situation, it's always for the same reasons. It's like, look, we were doing all this stuff and we wrote all the code as like basically a serial dependency chain. Like we do this and then we do this. We ask the server for this and we wait for it to come back, and then we look at it and then we ask the server for the next thing and then we look at it. And there's no way to speed those things up. You can't, there is no hotspot. It's the structure that is wrong. And so early in those kind of projects, you had to say, all right, we need to focus on batches. Like we need to send batches of things to the server and get batches of things back. And if we had just made that one small mindset change when we wrote all of this code, then later someone could have come along and hotspot optimized the batch processor and probably actually gotten the performance we needed. But without that architectural change early, we're sunk. And so that's why I say, the understanding what the structure is going to have to be for reasonable performance later is part of that first step if you're doing a real project where you're going to have to scale to anything appreciable. And here's the other bad part of that. Scale always bites you in the butt. I'm sure you know this in web better than anywhere else. You always think like, oh yeah, it was just going to be a 20 by 10 ASCII game. But then someone comes along and it's like, actually, we wanted to run this cool 10,000 by 10,000 ASCII map because we were doing this thing where everyone plays a different tile of the map in Twitch at 50 different Twitch streams, and all of a sudden it's dog slow and doesn't work, right? And so scale always comes back to bite you. So usually, even if I was doing a simple game like this, because I programmed games before, obviously, but if I was doing a game like this, I might still think about it as I do that prototyping phase. I'd go, okay, what have I been doing a lot of? Like how are these queries working, and where are the loops that do a lot of stuff? I'm going to think about maybe making some architectural changes to set that up to go really effing fast, because I know I'm going to want to eventually. I'm going to want the 10,000 by 10,000 tower defense with 50,000 players, each controlling a different tower, or whatever happens 3 years from now when this is an unexpected success.
Yeah, that makes sense. Yeah, because realistic, I mean, there could actually be a day, because the nice part is I did focus first on the networking side of things a little bit earlier. So I have, for ASCII, I have a reasonable set of stuff to compress it into a pretty small packet. So I've kind of prepared for that kind of eventuality. So I'm happy about that, which means now it's just really thinking about the gaming side of things. Because you could imagine that one day you could have 4 streamers, like a 4x4 go at it where each chat attempts to beat each other. And so like that adds just a whole different level of, okay, we went from 20 by 20 and now we are 100 by 100, and Squared does start to
catches up.
Things can get a little bit harder, and all of a sudden now it's like 150 by 150. Like now we're really,
it starts to add up, and
things start sucking all of a sudden.
Squared is not fun. Yeah.
So okay, this is good. These are all really good things to know and to keep in mind. I'm going to take these, I'm going to make something, and then one day I'll expose to you my said thing I've made.
You're gonna open up the flasher trench coat, and I'm just gonna see the whole thing, and I can't unsee it no matter how hard I try. Okay.
Tower defense right in your face. It'll be great.
Looking forward to it.
All right. Well, Casey, hey, thanks for being on. First off, before you leave, as always, what are some things you would like to plug?
Really, just come find me on computerenhance.com. That's it.
Computerenhance.com. How'd I do for spelling? I think you should start seeing it in the chat.
I mean, it looks perfect to me.
Okay. I have raging dyslexia, and sometimes when too many things get together, I can't actually tell anymore all of a sudden. Yeah, that looks like you. So, perfect. I nailed it first try.
You crushed it.
Crushed it. All right. Also, Buttsnake VPN.
Buttsnake VPN. Yes.
Never forget that. And I think you also have a Twitter, right? Let me pull up your Twitter. There we go. Tweeted. There we go. I don't call it X.
Oh, yeah. I don't either. I still say tweets all the time.
Yeah, I know, Steve. Well,
thanks for having me on, Prime. It's been a
fun.
pleasure as always. I love the show, and I hope you keep doing what you're doing for a very long time. I'm looking forward to this ASCII game and seeing how it goes.
Yeah, hopefully it goes well. Well, you never know, because now I have a Doom one under my belt. Now I have some ideas, because the Doom one was the worst case networking, right? Because that's like worst case ASCII game. It's just everything changes every single
it's very
click.
fast. Very
fast. And so now I have the idea. So now I get to take the next step, which is this is actually making it my own game. So very excited about this. Thanks for the support. Thanks for the wisdom. Honestly, the wisdom is more than, dude, it was worth a lot. So
anytime I can help, just let me know. I love being on. I love the show. Like I said, can't say enough positive things about it. So
let's try to find a good, because there was that one that I just showed you earlier, that YouTube video. Let's try to find time for that to come back on and discuss some of the waning, maybe dev attitudes throughout the game industry. And what's the root of that?
Yeah.
So, all right.
Absolutely.
Hey, take care, Casey.
Take it easy. Have a good one.